Was there, I think I answered the questions.
Yeah, I think you answered it. So we can only use the method 1, 2, 3 if there's a perfectly elastic collision, just making that
One dimensional, perfectly elastic.
one dimensional. And we're not gonna have the 2-dimensional because that makes the whole math weird, right?
If it's two-dimensional, you still have conservation of kinetic energy.
Yes.
Just the momentum, you'll have the conservation momentum horizontally and vertically.
So that would still be 2 equations for, or is that?
Two for momentum, 2 equations for momentum, and 1 equation for kinetic energy. You'll have 3 equations for perfectly elastic two-dimensional collision.
And we would have 2 equations for momentum based on the I hat, J hat directions, right?
Yes. And it turns out, in a two-dimensional collision, if one of, say A is at rest, so if one of them is at rest and B is coming towards it, A is gonna shoot down like that. If they are the same mass, that will be a right angle.
So, like, if technically pool balls are actually the same masses, they're
Yeah.
the same size. Physics.
Well, except pool balls also have spin, so you've got this extra thing on them.
Yeah.
So that's assuming that there was no spin in the ball for the right angle to happen.
Right, yeah.
Oh.
It's a closed system. If you bring in felt, then it's no longer a closed system unless you look at the change in the felt, probably the temperature of the felt.
Mhm. And that's a type of that type of question would be like an explosion question, right? A 2-dimensional one. I think I remember you talking about.
Oh, explosion? Yeah, that could be an example of, if it's an explosion, you start out with one mass at some velocity, then energy is not conserved.
Yeah.
But it primarily is, it's the reverse of the perfectly elastic collision.
That was Flubber-esque or whatever.
Flubber-esque is that you don't have an explosion in there.
Is impossible or something? I think that's what you said.
Flubber-esque is impossible.
What would be an impossible situation? Oh, never mind. That's just a stupid question.
I drop the ball and it bounces higher than it started.
Oh.
5-minute warning.
So for rotational motion, we always have to take into account the k hat and negative k hat directions, even if it's not torque. So before, when we were just solving simple angular kinematics, we had to take into account what direction is k hat and negative k hat.
I'm hesitating, I would say yes, I'm hesitating on the word always, but yeah, deep down inside, yes.
So
I mean, there are times in which it's sort of implied.
okay. So when would we say that the angular acceleration is negative then? Would it be when our k hat is pointing towards the board?
Give me a situation, I need more than that.
Sorry, the one that we were working with earlier, the
pulley?
yeah, the one, and then we had to look for the angular velocity, and then you started talking about the k hat and the k hat directions.
Yeah, if whoever chose k hat to be positive coming out, then the angular acceleration would have been negative in that problem.
So that would just be literally if we adjust our coordinate system.
Yes.
A little bit. I will
Same
not
has
do
always
that.
been true. That's the reason negative acceleration does not necessarily mean you're speeding up or slowing down. Because all you have to do is just change your coordinate system and suddenly, hey, it's changed signs.
Yeah.
Oh, it depends on where we start and what the acceleration is, right?
Well, the acceleration should depend upon the forces, or angular acceleration depend upon the torques.
But let's say if our change in displacement was a negative, that means our acceleration is negative as well then, right? If I'm getting this correct.
Change, say that again?
If our change in displacement is a negative, our acceleration should be negative as well, right?
Not necessarily. If it starts at rest, yes, I completely agree. If it's not starting at rest, it could just be, the change in the angle is negative, it could be already moving that way, and it could be slowing down as the torque is trying to stop it.
Oh, yeah, I forgot about that.
If the angular velocity and the angular acceleration are opposite signs, it's slowing down.
If the angular velocity and the. Is that it's because like I just can't wrap myself. I can't find like a physical example of like when would the acceleration go towards the board and why would it be negative, and why it would be positive for that one. Because when we were doing just simple projectile motions, I know like it's negative when the j hat is up because because gravity acts down.
So as this is rotating like that, the angular velocity is away from the board.
Yeah.
As I put my hand on it, I'm slowing it down. I'm applying torque. The friction that I exert on the wheel is that way. So it's applying torque into the board. So there's a case where acceleration is into the board, angular acceleration is into the board, angular velocity is out of the board. And consequently, it's slowed down. Somehow I don't think that satisfies the need there.
If I watch the video 10 times, I might get it. That's how I did. That's how I understood the ladder problem. I just watched it 10 times, like replay, watch it again, replay, watch it again.
I'm gonna do that.
Until like,
Yeah, the same thing holds true for physics papers too. If I read this 10 times, after 10 times I'm going, okay, I'm getting the gist of it.
Yeah.
I couldn't explain it to anyone yet, but I got the gist of it.
like I want to understand to the point where I could explain it to myself, and when I explain it to someone else, they'll understand it too. Because I have a friend who's taking this class next semester, and she keeps getting scared about it. So I need to be prepped for her to.
You know, F equals ma.
Yeah.
That is pretty much that, and F equals negative K delta X. Those are the only two physics equations. The rest is just math and definitions.
Just like what Ibrahim said, he'll crawl so we can walk.
Anyway, there it is.
Do you want to see?
Oh,
Notes for what?
Pratika. Good.
Let me grab my notes real quick and show you.
Robin.
So one day.
Oh, wait. Centripetal force, dude.
Oh, yeah,
I still
yeah,
need to
yeah.
look at that because the graph.
Yes.
There's one day I
or-
missed, and it was right before, because this was on Tuesday, where we started talking about, because Tuesday I jumped in and it was just cross products, so I'm guessing Monday is the first day he explained cross products.
Stop the-
Monday, yes.
Well, this is the earliest notes I have.